Hello, advanced algebra students, and welcome back to another video lesson as we continue to explore the inverse of functions. Yesterday, we explored the top two of our targets. You can find the inverse of a function if it's given as ordered pairs, and we can find the inverse of a function if it's given as a graph. Today, we're going to look at finding the inverse of a function if it's given as an equation. How do we take an equation and find the inverse? What I encourage you is that a lot of this, in my opinion, is review. It's just learning how to use some of our previous material a little differently. All right, so here are a couple of warm-up questions. I'd like you to pause the video here and answer them if you would, please. All right. Number one is all about the composites, finding f of g of -2. So we've got to plug in -2 to that g function, and that's going to give us 13. And then we're going to find f of 13. 13 squared is 169. 169 times -2 is going to be -278. -278. G of f of -1. So when we plug in a -1 to this function, we get +1 times -2, which is -2. And then we're looking at g of -2. G of -2 should be 13. Last but not least, g of 0. Okay, so we got to plug 0 into the g function. We get 7. I plug in 0. And then we're going to find g of 7. So take 7, plug it into the g function. -21 plus 7 more is going to give us -14. -14. Those, again, were composites. Number 2, give the inverse of the following. The inverse. Well, we're just going to flip them, right? When we have ordered pairs, we just need to switch the x and y. So the first ordered pair becomes 3, 2. The second ordered pair becomes 7, -3. And the last ordered pair becomes 6, 4. 6, 4. And we have that as a set of ordered pairs. So that's my inverse. This is equal to f of -1 of x, the inverse. Using that, it wants us to state the domain and range. So when we have ordered pairs, the domain means we just list the x values. So the domain is 3, 7, and 6. The range is going to be 2, -3, 4. Listing those y values. Okay, domain goes with x, range goes with y. Last but not least, will the inverse of this function of the graph, will it be a function? It will not. Why? Well, it won't because it fails the horizontal line test. So it fails the HLT, that horizontal line test. And again, that means if I were to flip this graph and rotate it by using the points, it would look something like that, meaning the inverse itself would have failed the vertical line test. Okay, so those are all things that now we've kind of talked about the last couple of days. I want to take one more look at how do you get the inverse from a graph, right? How do we actually take this graph of these points and they're connected together here in the middle, just trying to make a bigger line. How do we find the inverse of that? Well, the most simplest way, in my opinion, is to create an XY table of the graph. Figure out your coordinates, if you will, from this graph. So let's just start going left to right. -4 for the x and 4 for the y is this first point right here. The next one is -2, 4. The next one is 0, 2. The last one, 2, 2. So that's the original graph. If I wanted to find the inverse and be able to graph it, right, we're going to take and flip-flop or switch around those x and those y values. So the first one becomes 4, -4. And then we've got 4, -2. And then we've got 2, 0. And then we've got 2, 2. And we can go ahead and graph those, right? So 4, -4 would go down here. 4, -2, 2, 0, and 2, 2, so that we would have that graph. And that was what our inverse would look like. So the best way, I think, and most efficient is to just identify those ordered pairs from the graph or find some and then switch the x and y's, right? That's all the inverse is doing, switching the x and the y. Now, before we get to today's new topic, I've got a question for you. Take a minute to pause the video and solve this equation for y. Solve the equation for y. If it's asking us to solve for y, that means get y, that's a very sloppy y, get the y value by itself. We need to get y by itself. So I'm going to subtract the 3x to both sides. We're left with -9y equals 210 minus 3y. And then we got to divide by -9 to the whole entire other side. So that y equals 210 minus 3y over -9. If we wanted to, we could try and simplify it by putting each piece, whoops, forgot my negative sign, each piece under with -9 underneath, and we could simplify from there. Okay, but that is how we can get y by itself, and that's an important skill for what we're going to be doing today. Inverse of equations. Based upon what we've already seen about inverses and some of the stuff we've already done, how do you think you're going to find the inverse of the following function? Well, the first thing you have to remember is that f of x replaced the y. So rewriting it this way is the same as what's above it. This is just writing it as a function. This is writing it in slope-intercept form. So remember that that's y. And what we've done all along to find the inverse is to switch the x and y. Well, we're going to do the same thing here. I'm going to switch the x and the y in that particular equation to then find the inverse. Okay, so that's the first step, is to switch x and y. Now, we then solve for y. We want to know what the equation is. Solve for y. X minus 11 equals 3y. And then divide everything by 3. Right? X over 3 minus 11 over 3 equals y. And if we want to, the most appropriate way to say it is that the f inverse, the function inverse, is equal to x over 3 minus 11 thirds, to show that we found the true inverse. So as I've kind of tried to mention, this isn't a new skill. You've already learned a lot about solving for y and isolating variables. It's just understanding how to apply that to the inverse of equations. All right, so here's a couple practice problems. All right, this is from your packet, page number 13. I want you to try and think about what's happening. Fill in the blank. If f of 4 gives us 10, then f inverse 10 gives us, well, that's 4. Right? This is x, that's your input. That gives me my output. Well, they moved and they switched the y to become the x, and so the x has to become the y. Look at this one. if the inverse 9 gives us 5, then the function 5 gives us 9. Right? That's that switching x and y part. That's all that's happening in this. Number 2, if we're given h of x equals negative 3x minus 2, find the inverse function. Right? So this is like saying y equals negative 3x minus 2. We're going to flip them around to say x equals negative 3y minus 2, and then we're going to solve for y. X plus 2 equals negative 3y, and then we divide everything by negative 3. Instead of writing it as y, I'm going to write it as h inverse, the inverse function of h, equals x over negative 3 plus 2 over negative 3. And there's our inverse. Why don't you pause the video and try number 3? All right, so again, this would become our y. And so I'm going to switch them right away. I'm going to say x equals 1/4 y plus 7. And then I'm going to solve for y. X minus 7 equals 1/4 y. And to get rid of 1/4, we could divide by 1/4, but that's the same as multiplying by 4. 1/4 times 4 is going to give me y. And if I multiply times a fourth over, or times 4 on the right-hand side, I've got to multiply by 4 over here, which is 4x minus 28. Or a, the inverse function of a is going to equal 4x minus 28. 4x minus 28. Okay. Number 4 would be much of the same way. You're going to do the same kind of process, okay, where y equals this, switch the x and y, and then you would solve. But I want to go jump down here to number 4, finding the inverse of this one. And again, this would be my y. And so if I switch this, I'm going to get x equals y to the 3/4. Y to the 3/4. Now this goes back to the mini test that we just had. How do I get y by itself? Well, the object is to raise it to the power of its reciprocal, because I would multiply these powers. 3/4 times 4/3 is 1, meaning I get y to the first. But if I raised this side to the 4/3 power, I also have to raise x to the 4/3 power. Or the inverse of n is going to equal x to the 4/3 power. So it's kind of tying back in some of those rules that we were just talking about. Okay, tying back in some of those rules. So hopefully you see that finding the inverse of equations and rewriting them as equations is a little bit of review. If you have any questions, please make sure that you reach out. And otherwise, until next time, everyone, stay safe.